Hello, everyone, and welcome to another round of Encord webinars. I'm joined here today by Stephen, who will kick us off very shortly. Stephen, over to you.
Absolutely. Thanks, Nico. Hello, everyone. Welcome to today's webinar, From Data to Diamonds, Unearthing the True Value of Quality Data per ML. My name is Stephen. I'm a machine learning developer advocate here at Encord, and I'm joined by Nico, who is the product manager at Encord here. I'm super delighted to bring this to you together, hosting this. Perfect. All right, so the agenda for today. So first off, we'll consolidate what we know. We'll introduce where we've been in the past 3 years in AI and what we know right now about the advancements in AI, obviously with the progress you've seen so far over the past few years. And then next, we'll share our learnings from talking to hundreds of ML engineers and data teams about why data quality is important. And then based on these conversations with ML engineers, we'll share a 6-step process on how you could easily assess your data and move into improving your data quality, right? And Nico will jump into the demo, we show you hands-on how to implement the 6-step process and how you can essentially go from data to diamonds. And then I'll be back to show you to take your questions and answers, and then we'll wrap this up. So it's going to be a fun and exciting hour, and we're delighted to have you here with us. Perfect. So the future of AI is in the present. So what does this mean? I think we can all agree that over the past 9 months, AI has been pretty much everywhere. And with large language models taking center stage across after the release of ChatGPT, followed by AI craze by investors, entrepreneurs, and media, venture beats, and whatever, TechCrunch and so forth, it is pretty much clear that we're at an inflection point in the industry. However, language isn't really the only data modality that has been seeing that significant growth. And as computer vision engineers, we've been seeing the release of visual foundation models. That's really been exciting, getting us excited about, detection, segmentation, classification problems. And contrary to the classic deep learning models, VFMs can generate images, can now make predictions based on prompts instead of just learning like specifications in your images. And they are now more general in nature, but can be fine-tuned to, although they are more general, obviously, but they can be fine-tuned to your use cases, your objectives, your domains, and whatever industry problem you're trying to solve. And then obviously, you can see that more of the systems are reaching superhuman level, they're reaching levels that human performance, we deemed human performance to be the benchmark before now. Right, and then obviously you can see here on archives, if you've looked over the past 3 years, every ML paper, the exponential growth of ML papers pretty much skyrocketed, right? Almost every paper is ML paper. You look at the citations, you look at Google Scholar, literally every paper there, you can see, has some ML component into it. And then you see consumer applications like ChatGPT, the Bing search and stuff like that. These ones have been incredibly helpful, in showing us how much AI has grown. And obviously autonomous vehicles, for example, you're seeing growth in, fully self-driving cars. The growth in fully self-driving cars, as well as how the usage as well. So look, yeah, so AI is becoming exponentially useful, especially for big companies. And, it's become a moat. It's become the key advantage these companies are striving for. We're seeing a lot of investment. We've seen a lot of growth in there. But what is stopping it from being useful for the rest of us today? And the reason is that a few companies have actually been able to get models to production. Obviously, we know that Google, we know the OpenAI and stuff like that. These guys are actively getting models to production, but there's this gap between just AI, meaning you're seeing the progress in AI, and getting to show that to investors and everyone gets excited about it and stuff, and getting to the point where you call that useful AI. Now, what do we call the useful AI? So essentially, useful AI is what you take to production that helps solve your real-world use cases that your users use and they don't find any problems with it, right? They find the value, it improves their experience, it helps solve the problem, whatever domain you're trying to solve, it's actually there and helps, under the hood, solve those issues. And because the technology is quite new, we're still naturally seeing only a few companies on the left-hand side, which is just that's AI, just AI for them because, that's their mode. But as we grow, we're starting to see that a lot more companies are starting at the points where they want to figure out how can we make AI useful. But then again, there's this chasm, and that's the chasm we really want to talk about in this webinar. Meaning, how can we go from just going from just this is AI, this is the progress in AI, to going into useful AI that can actually be useful for our reward use cases. So let's look at some of the issues. Yep, there's a hard lesson to be learned really when finally getting, you get proof of concept models to work. You try the models and you're excited, show it to your manager, you show it to your investor, but then all of a sudden there's this additional set of requirements you probably didn't consider when you're trying to run the demo of segment anything, for example, or you're trying to test out clip or grounding for your problem. So to move it across the chasm from just AI to useful AI, I think you have to make sure that you do a few things, right? You have to make sure that your model is reliable and enough to work for your use cases, it's robust to outliers and can handle whatever edge cases you are. So for example, you're running the manufacturing use case, for example, and your use case wasn't considered when Meta was training like segment anything. So you need to ensure that the models are robust enough to these particular edge cases, or can actually solve these edge cases, and they can generalize well to production instances. And for critical applications, you need to ensure that these models are also explainable. You're in the healthcare industry, you're in the banking industry, you need to make sure that these particular models could help. And then you have the data to fine tune these models, because ordinarily these are really large models, for sure that the most way to get the best out of them is to fine tune them. So usually most companies don't have enough data or don't have the capacity or infrastructure to be able to fine tune these problems to their specific use case, right? Or you also have to think about the operational cost of running this particular models in production. These are large models. There's always that complex engineering overhead on how you can actually get these models from the development environments to your production environment without having to bottleneck both your ops team as well as your annotation team, right? And then one of the issues I think we see as well with moving from this left-hand chasm of just AI to useful AI is just seeing how you can reduce the bias in the output of the model you get. So what's common between this chasm? I think we're probably familiar with most of these concerns. Some of us here are ML engineers, ML practitioners. We are pretty much familiar with these constraints. And at some point, we just start to wonder, what's really is the common theme behind between this chasm? Data. Data, because it's you've had over the past few years that data is the new oil. It's the big data, it's useful and stuff, but it needs tons of work to be able to get you from just AI to useful AI. And that's the key concern we are looking at in this webinar. So data is the new oil. As you can see, it's not just data you need quality data. And that's the difference between companies that have significant moat and those companies that are still struggling to see this usefulness in AI. How can you go from just having data, which is pretty much everywhere these days, to having data that is refined and tuned for your use case, curated, tuned for your use case? So why is improving data quality important? So raw data has potential, but its true value, obviously, can only be unlocked when you've gone through that refinement. So whether it's language models you're building, whether you're training, large model architectures on large computes, good data is and will continue to be one key component that provides or produces the best advancement in your AI application, right? And we know this because we've had numerous conversations with data and ML teams to know what that really good quality data is the foundation for proactively leveraging the progress in AI today. And with that, I would hand over to Nico to really talk about the critical findings we found over talking to hundreds of ML engineers and a few data teams on what issues constrain getting over from the left-hand side of the chasm, which is just talking about AI, to actually deploying that to real-world production use cases where their users are seeing value from it. Over to you, Nico.
Thank you, Stephen. I always love this analogy, data as the new oil. Most of you might be familiar with this notion of model-centric and data-centric AI. Here at Encord, we're all about the data, as Stephen just alluded to. And as such, we've dwelled into many conversations with ML engineers over the past years to uncover exactly which pain points they're facing on their journey to improve their data quality. So let's take a look what they're saying. Of course, the list could be a lot longer than what you're seeing here, but generally most agree that high quality data is the foundation for generating accurate and reliable models. As in moving from the left side of the chasm to the right side of the chasm, as Stephen alluded to before. One of the questions we always ask ML teams is, what is stopping you today from moving from POC to a real world application? And a recurring theme has always been data quality. We distilled all of the takeaways into 4 main points that we'll touch upon throughout this webinar. The data and label quality, whether it be noisy, corrupt, and unwanted data, wrong and misplaced labels, data storage is slowly becoming landfills, Many of you told us that extracting and collecting relevant data for training is hard and time consuming. And when it's then used for training your models, it's often noisy, insufficiently labeled, and low quality. Next up was immature toolkits. So many of you alluded to the fact that there are a lot of missing and immature tools in the market. And a lot of people, they still only use Jupyter notebooks or manually scrolling through their images and videos to find the needle in the haystack to train their models on. And then lastly, integrations. A lot of time is spent on data migrations from tool to tool and label transformers from one format to another. And a lot of you have mentioned that these integrations and customizing these different tools and open source solutions have caused more than just one headache. So if we dive into data quality a bit more into detail, we can see at a high level, there are three common issues: data quality errors, label quality errors, and model failure modes. First, data quality errors. We all know how duplicate samples can screw our training data and impact the training of our models, leading to a highly overfit model. Similarly, corrupt samples and data can lead to incomplete and improperly formatted data, having a big impact on our models down the line. Noise in our data can obscure underlying patterns, making it difficult for a model to learn effectively in our respective domains and use cases. And lastly, data outliers, which, funny enough, there's a lot of different opinions on, because as being outliers, they can both represent valuable edge cases or misleading anomalies that you want to remove from your data sets. On label quality errors, we heard three main points: missing labels that can lead to gaps in your model fitting the data and learning the underlying problem of your use case; inconsistent labeling that can lead to unreliable model outputs. An example here will be whether to include or exclude the occluded objects in your data. And then lastly, a high class imbalance is often a problem. A high class imbalance in your training data will impact your model performance and lead to your models often being biased towards the majority class or classes. For model failure modes, many of you stress the importance of identifying and addressing model blind spots and edge cases. These are specific real-world scenarios that are not present in our training data, and as such are very hard to find and predict correctly. An example you see here on the image to our right is, for example, a very bright scenario on an autonomous vehicle case study, where the moment that the sun hits the camera, you see this very bright image, and the model might be confused whether these three cars to our right side is a truck or not. And lastly, data drift, closely related to these edge cases. As your data drifts over time, we as ML engineers need to continuously reevaluate our training data, retrain our model, and as such, continuously monitor and adapt our model as new things and new objects arises. When asked ML teams about how they go about understanding their data today and understanding their model performance, there were three main methods that kept coming up. Some of you probably know these. The most painful one, manual inspecting of images and video frames. So for example, see that you go through an entire folder of images one by one within your S3 bucket, or you go through hours of videos searching through to find those specific areas where your model would benefit from training on it and thus sending it for annotation. Second way was one-off scripts in Jupyter Notebook. This was probably the most used one. So here, a lot of ML engineers, they write quick scripts that they can reuse to analyze the distribution of your data, distribution of your classes, and conduct different high-level data analyses on the fly. And lastly, of course, we all know weights and biases. Very, very common to just conduct standard model-centric analysis on top of your models, but this does not take into account your data and your data quality. So how does these problem and pain points impact our businesses and our models? Firstly, there's naturally a delayed time to market for our companies. Data quality issues can significantly delay model development and model deployment. This is true as many ML engineers end up spending time identifying and correcting issues, and moreover, a lot of overhead in processing and managing and curating the data, which leads to a slower process in bringing actual products to market that can help consumers and users around. Secondly, increased costs, mainly annotation cost and MLOps costs, because without a smarter way to curate your data, you see an increase in annotation cost as too much redundant data is sent for annotation. And the added constraint of operationalizing these ML applications and open source tools, managing multiple data migrations and label transformers, conducting your data cleaning efforts, will increase your DevOps and MLOps expenses. And all of this ultimately leads to poor model quality. In the end, worse data quality will affect your model, and spending excessive time on all of these data-related issues will leave you less time for actual model optimization, model improvement, and model innovation. So with that said, how do we then move from data to diamonds? We sat down with our team and put together a short 6-step process designed to be iterative and adaptive to your specific use case and to your specific data environment and data modality. The process starts with defining your problem and objective and deciding what type of model and data you need. Let me just really strike here that this is the most important part of starting to create a machine learning model, is to figure out what is it that we actually want to do and what is the problem that we want to solve for a user or a consumer. And assuming here that you've already collected a bunch of data, the next step is to conduct data cleaning to ensure a high quality data set and remove any questionable samples, followed by a curation step to create a balanced and diverse data set. Next, you annotate the data, either with your own team or with an external annotation partner, whereafter you analyze the labeled data to ensure it is error-free and meet your quality standards. Lastly, you train your models, whereafter you begin anew. This might look like a very linear process, but in real life, it's more of an iterative loop, going back and forth between cleaning, curating, labeling, training, before refining your objective again as you learn more about your production environment and the use case in question. Let's dive into these one at a time. Firstly, defining your objective. So before thinking about data quality, again, it's important that we define what is it that we actually want to do and achieve with a machine learning model. What is the user problem? What is the desired outcome? And what does success look like to us for this outcome? What type of machine learning solution or model would be best to apply to the specific problem? What data is required? And then lastly, how would an ideal solution perform in a production environment? Let's try and take the use case that we'll be demoing shortly on the COCO dataset. In the scenario I'll be demoing here, we'll be playing around with the COCO dataset and try to prepare a dataset for a pain point observed in wildlife conservation, identifying and cataloging rare wildlife species. The outcome we're looking for is an automated system that can accurately identify wildlife species and classify them. I think the best way here would be to apply a detection model, such as a faster RCNN model, to detect and classify the different species in a production environment in real time. And then lastly, as we don't have access to any wildlife open source data or any data collection process, we'll just be using the COCO dataset for this demo. But in a real environment, we'll of course go out and find a way to either crowdsource or collect our own data. Moving on to data cleaning, finding and fixing quality issues. So in the context of our wildlife detector, let's dive into some of the cleaning techniques we could use and that we will use. At Encord, we divide the cleaning techniques into 2 different methods currently: quality metrics and embeddings assisted. So using quality metrics, we can filter, search, and sort out any messy data we find in our data set and exclude any noisy data samples, such as images with irrelevant or misleading information that's not good for our model. We can also surface unusual image properties that does not reflect the real world scenario that we'll be running our model in. These image properties could be extreme saturation of the images, weird colors, blurriness, all things that will not help us in detecting wildlife in the real world. And then lastly, we can also detect corrupt images with no meaningful information to maintain the integrity of our dataset. For embeddings-based cleaning techniques, we can leverage embeddings from our pre-trained layers of our models, or an off-the-shelf foundation model in our case, to help clean the dataset. For example, we can find samples that are significantly different from the training data distribution, and we can also remove any duplicate images using our different embeddings-based techniques. Ultimately, our goal here is to clean out any errors, improve the dataset diversity, and prevent our models from overfitting to any image features. And just a quick disclaimer here, for those of you that are new to Encord and new to data-centric AI, When I mention quality metrics, it refers to any image property we can extract from an image or an object on an image. So in our case here, we automatically calculated 40 of those out of the box in Encord Active, so you can focus on what's important for you. You can also take these quality metrics and analyze your data set a bit more holistically with various different out-of-the-box visualizations. So as you see here, you can compare your metrics in a 2D plot. You can see the distribution of our metrics, how a model performs according to each metric, and find any potential outliers. And in case you have any custom metrics in mind, we do support building your own custom metrics and also custom consulting on specific use cases if there's anything that you need here. So please do get in touch if there's something that you'll be interested in. Curating our dataset is up next. You're going to see a lot of the same functionality here in Encord Active can be used for different parts of the recommended workflow. That's of course on purpose. We want to have one tool that can solve a lot of different problems. So for curation, we can use a embeddings assisted technique to identify sparse regions in a dataset and help us curate a diverse dataset. Model-assisted techniques can be implemented if you have a trained model already. Here you can use your model to identify areas where your models are struggling and then curate similar images. So very similar to the model failure mode use case that we discussed a while back. Or if you want to go down a more advanced route, you could sample your data based on different acquisition functions, such as, for example, the proximity to the decision border or least confident. Lastly, I've highlighted a few hybrid techniques that we don't support yet, but I'm very excited to explore more in depth with our users and customers in the coming quarter. Here we can think about different combination of the two techniques above to cluster our data in interesting ways. And we can also look at deploying different active learning-based approaches to automatically select what we want to send for annotation and what we want to train our models on. If you're interested in any of these techniques, please do get in touch after this webinar, as we're currently beta testing these features in this quarter and would love to try it out with you. Next up, annotation. I'm not going to touch a lot about this, but when we've collected our samples from the wildlife experiment, we'll of course want to get everything annotated. For this, we're going to use Encord Annotate, our own in-house annotation platform. Here we've built these two tools together in a very intuitive way, and as such, there's a tight integration between the two products. And we have the option within Annotate to set up different quality assurance workflows, similar to the one we see here on the screen, to really ensure we have the highest quality labels before we sync it back to Active for our label validation step, which is next up. So for label validation, there's again a few different techniques. Here we can apply a embeddings assisted technique where we can potentially investigate any cluster disagreement in the label embeddings. So we can find any inconsistencies between the different embeddings of our objects and find any potentially wrong classes. So this is mislabeled objects. This works by comparing the label embeddings of each object with their nearest neighbor labels in the embedding space and then comparing how their classes are. We could also apply a model-assisted technique. If you already have a trained model, once again, we can use the model predictions and overlay them on top of our ground truth labels to spot any potential high confidence false positive predictions, which can in some cases act as a good heuristic for finding label errors. You could also look towards academic literature and test out some of the new confident learning strategies that are being posed currently that can be helpful at identifying label errors in your dataset. And lastly, of course, there are quality metric-based techniques. If you want to take a quality metric-based approach, we can investigate Encord's own proprietary annotation quality metric or other metrics such as shape outlier, border proximity, redness, blurriness, and so on and so forth. And then lastly, we also have a label assertion technique embedded into our quality metrics. So here we can look at different label assertions such as broken tracks in videos and different types of occlusion in your images and in your videos. There's a lot of information. I hope you're still with us. Now let's jump on to a live demo. We're going to demo creating a dataset for wildlife detection on the COCO dataset. What we'll go through is first a step-by-step guide on how to get started. We're going over all of the functionalities in the tool before diving into our data cleaning and curation step. Then we're going to send our data into a collection we can send to Encord Annotate for annotation before syncing it back to visualize our labels and validate our labels. In the end, we'll discuss a few automation potentials, and then we'll go over to the Q&A. 1 second, then I'll get it set up. So now you can see here on our screen, we are within Encord Active. Encord Active is embedded within the Encord platform. Find it over here in our left-hand side. And it's a tool for data curation, label validation, and model evaluation. If we see what we have here in front of us, we have the COCO 2017 dataset for the specific demo potential. We have our Explorer in the middle. So this is our grid view where we can visually explore all of the images in our dataset. And we can open up each individual image to get a better understanding of the objects, the data in question, and any potential metadata that's on it. If we go in here in our display, we can hide and show our labels. In this case, we're doing a data creation without labels, so let's just hide them for now. And in the overview, we can see a quick overview of all of the images we have in our data set and some potential issues. This is one of the benefits of using a tool like Encord Active, because we're running a lot of different automated systems in the background to highlight some of these issues for you front and center. So for example, if I click on the duplicate icon here, we can see all of the potential duplicate images in the dataset. And we can then mark our different duplicates and exclude them from our dataset if we want. I'm not going to remove them now. Go back here. And we can go back and remove the filter. We can see here that the duplicate is based on the uniqueness metric. If we look further, we can see the different tools that we have at our disposal that can help you easily query, sort, filter, and slice your data. First, top left, we have our natural language search bar. Here we utilize embeddings from your model to find similar images to your natural language query. Next to it, we have our external image search, where you can import an external image and then search by that as you wish. Then we have our different views. So we have our data view, where we have the data in focus. Label view, where we look at each individual label, so each card represents a label. And our predictions view. Here we see to our right, an overview of all of our prediction types, some of the potential issues with our predictions, and our model performance, which will come in handy later. So if we go back to data, I have one last thing I want to show you before we dive in, which is the sorting functionality. This is one of the bread and butter functionalities in Encord Active, because it allows you to very quickly find any potential outliers in your data set. So here we can sort by all of the aforementioned quality metrics. For example, we can sort by aspect ratio, and we can sort it by, rank it by ascending or descending to see both the very horizontal images and the very vertical images. This might be some cases here where we might want to include or exclude specific types of image properties. We can also move on to other types, such as the brightness metric. We can see dark images, we can see light images. And we can look at, for example, blue value, see all the blue images. So a lot of different ways to slice and dice and investigate your data that will help you on your data creation and data cleaning journey. I think the last thing I want to show before we dive in is the different filtering options that we have. So within filters, we can add here and filter on our different quality metrics and on a bunch of other properties, such as your custom metadata, your dataset name, data units, your type of data, classes, and annotators. So though you might think of, you can filter, slice, and search for it in Encord. I can give you an example here for brightness, where we show you a histogram of the distribution of all of the images here on our brightness metric. And then we can filter as we want to hide or show more or less images. Let's go back. Last thing, embeddings. So we discussed embeddings quite a lot previously. Within the embeddings view, we can visualize in 2D the embeddings for each specific image. In this case, we'll use the foundation model clip to calculate embeddings. But of course, in the future, we want to implement a way to import your own custom embeddings and visualize those in here. So here, all we do is simply drag and drop within the embedding space. We can then zoom into that specific area of interest. The embeddings are calculated both on a data level, but also on a label level. So we can go in and see how the objects, these are the boxes or segmentations, are represented in the 2D embeddings space. Good. There's a lot of information. Let's get ready to dive in. a second. Before we start, I'm going to say here that I've cheated a little bit. I've already created a animals collection to get us started. A collection is an abstraction on top of your data that helps you store and manage all of your data into smaller groups you can then later use for different actions. This could be actions such as creating a data set you want to send for annotation. If you're doing label validation, it might be a collection of label errors you want to tell your annotators to relabel, or you want to mass relabel yourself. Or it could be collections such as train, test, val split for your model training later down the line and your model evaluation. There's a bunch of different use cases, and we're looking forward to hear from all of you what you want to use these things for. Okay, let's take the animals and visualize in Explorer. We will not be conducting a thorough cleaning and curation, as this will of course take multiple days, but I will show some of the critical components of a workflow. And then first here, let's navigate to the collection. And here your first intuition when you see a collection might be to quickly go down and then actually start marking the images that you either want to include or you want to exclude. But clearly, before, take a step back, familiarize yourself with the data set and approach it in a good and systematic way. So let's start by exploring some of the outliers here in our data set. We can look at the aspect ratio. Again, we see there's a lot of very horizontal images, also some very vertical images. We clearly see here there are some wildlife, animals. These will definitely be useful for later. We can also look at the blue value, a lot of marine life. And the other end, see a lot of black and white images. These we definitely want to exclude, as in our production environment, we do not want to see any black and white images. Last one we can look at here is the brightness. Yes, we do have some night images. That's good in our case here. We do expect that our wildlife detector will run sometimes at night. And on the other end, we also have some bright images. But it's been clear here now just by looking a little bit at the data set and exploring some of the outliers is we have a lot of images here that are completely out of sample and that are not relevant for model training. So let's start out to conduct some curation and create a smaller collection for some of our wildlife images. I think what we want to start with today is to take the embeddings plot and try and dive into an area. Maybe here we see there's a big chunk. Let's go in and see what's hiding here. Here we see this specific area of the embedding space represents just the type of images that we're looking for. So I can now select an image, use our dropbar to select all, 49, and we can now add them to our wildlife dataset that we want to use later. Let's submit. It's all now added into collection. We can clear this selection and go back and reset our filters. We can also try out our natural language search. So let's try and search for giraffe. I think I saw one of those before. What happens when I hit into here is that we ping the model in the background and we load the embeddings into memory to start conducting a similarity search. The first time we do this, it's going to take a little bit of time to get started, but on subsequent iterations, this will be a lot faster. So we can see now here, all of our giraffes has been loaded in. Let's go take a look. There are indeed a lot of interesting objects you can use. So this time I'm going to hold Shift and I'm going to mark all the way down to the end where we see there are no more giraffes in our similarity search. So that's just around here. Add it to our collection and send it out. Again, in a real life scenario, we would spend a lot more time with this, but just for the sake of time, we're just going to move forward. One thing I did notice is that we saw one example up here of a giraffe. It's not really a giraffe. Let's try and dig a little bit deeper. Here, these are some of the issues that you sometimes see when you use similarity search. You get something that might look like what you're looking for, but it's not really. So for this one, let's add this to our selection and remove it from the collection we just created. Here, wildlife, submit. This is, of course, an iterative process. We go back and forth between different areas. We can try other ones here. Let's try and search for bear. See now it runs a lot faster than it did before. And we can now mark all of our bears, some polar bears and some wild bears. Oh, and then we have some other. That's out of sample. We don't want them. So let's go here, collection. Boom. Then we can also try our external image search. Let's first delete our bear search. Click here. See, we have an image of an elephant here. Let's try and pop that in. Once again, we're loading the image into memory. We're extracting the embeddings, and then we're comparing that with the embeddings that have been calculated over all of the current images that are now within our animal collection. This will take some time the first round, but the second round, it'll be a lot smoother. Let's go again. Take our elephants. Let's go down here and add it to our collection. Oh, that was the animals. We of course want to add this to our wildlife. Great. Now imagine we've spent 2 hours, 3 hours, really cleaning our data set, curating our data set, and we're now ready to move ahead to the annotation step. Let's try and click on our collection. We can now mark our wildlife collection over here. We can send it for annotation. So we do this by creating a data set first. Let's call this wildlife data set for annotation. And our data set the same. Hit create. And then a data set and a project will automatically be created, and you can just go in and attach your workflows. So we click here to open the newly created project. And then if I navigate up here in my tab, go to my Encord platform and see that the project has been created. 222 tasks, matches what we have in here. Now we can go in and add our collaborators into the project, and we can have them start labeling and reviewing. Just give you a quick example. Of course, this has already been annotated as it is the COCO dataset, but I can then use the intuitive labeling interface from Encord, submit their annotations one by one. You can also use some of the automation features that we have. Afterwards, reviewing them. And once the entire dataset has been annotated and reviewed, all of the labels are synced back into Encord Active. This is the power of the platform and having these two built very closely together. So now imagine day has passed, the team has annotated all of our dataset and is now synced back into Encord. Now we can open up our wildlife dataset in the Explorer. Let's move our search from before. We can go to display. And now imagine that these labels have been created by our team. We can now visualize these one by one within the platform. If I go to my labels view, as mentioned in the beginning, here we see a card per label in our dataset, and we can now start validating and seeing if we can find any label errors. There's different ways to go about this. Of course, we don't want to expect this label by label. We can have cases where we have hundreds of thousands or millions of labels. We want to find some more holistic approaches to this. Firstly, what we could do is we can go in and just look at this class by class. Let's go in here and select the class. Take the first bear that looks relevant. And now we can see our different bear annotations. Oh, this looks like annotation error in the COCO dataset. This is definitely not a bear, this is a pig. So let's definitely remove that one. Add to selection. Go back and remove that one. There's no need here to re-annotate it as we don't want to use this pig in our training data. Let's just remove it from everything. Once again, here, what looks like a bear, but it's actually a sign. Definitely, we also want to remove these from our data set. Let's click both and remove. So imagine this process takes hours to go through. We can go class by class. We could also take some other more detailed approaches. We could then go and look at our annotators to see who performs well. In this case, we can see at Gorkum, he's annotated a large part of the COCO dataset, and we can go into the each annotations from Gorkum. In this case, we see here's a horse annotation, but it's clearly not a horse. That's an elephant. Let's add that to our selection. Go back, create a new collection. This time, we want to create a relabeling collection. This will be sent back to the annotators to relabel. So Gorkum, you'll receive a notification once I send this collection back that, hey, now it's time to go in and look at your labels again. You see the next one here, annotated as a zebra. That is clearly a cow. Let's also add the one to our collection. Here, relabeling. Good. Let's remove our filters and talk about some of the other ways we can look at our labels. We can look at it from the embeddings perspective, as discussed before. So in here, we can go in and see some of the outliers and see what kind of classes they represent. Let's try and go down here and see if there's anything interesting. Go in. Clearly, here's a lot of zebras. And interesting enough, a zebra here looks like a zebra, but it could also be a horse. That is indeed a zebra. Interesting one. We can go do this process over and over again. Then we can look at our different annotation quality metrics. Let's go back here, reset our filters, go to our quality metrics and take them one by one. If we start with the aspect ratio, we can use these to highlight, in this case, animal classes that have either very vertical or horizontal annotations. We might not want to feed some of these very horizontal or vertical images to a model, as they would not represent what they will see in the real world. An example here is this zebra annotation, which is heavily occluded. Depending on your use case, you might decide that this is not the type of annotation you want to train it on. You're looking at identifying zebras one by one, not necessarily in a big group. So in this case, you would take this annotation and either ask for relabeling or remove it entirely from your dataset. Once you're done with your process of digging into your annotations one by one, by all of the different quality metrics, the embeddings, we can now send this for relabeling. So we go to our collections. We mark our relabeling campaign. Again, there's only 2 images and 2 annotations, but let's imagine there's more. Click send for annotation. We can then send it back with a priority very soon. And we can leave a comment here, say, Gorkim, please take a look at these annotations. They'll be submitted. And now Gorkim, he can go in and take a look at his reopened tasks. When all of the labels have been removed and you get all of the flagged mislabels back to active, we're ready to export our labels and start our external model training. Our next step after we've trained our model is to import our predictions back into Encord Active, where we can then explore our predictions more in detail, as alluded to in the beginning, from here, and we can conduct detailed model evaluation and analyze our different model predictions. But I think there's something that we'll save for the next webinar. Please do let me know if there's something that you're interested in. And now let's go back to the presentation and back to you, Stephen.
Yeah, thanks, Nico. We had a few questions while you were on the demo, and I thought it'd be interesting to touch on those before we head over to the pre-submitted questions. Now, just going back to the demo, I think you should be able to show images that have low annotation quality. Just going back to, under the labels,
Yes.
Mm-hmm.
What was the question here in the chat?
Joe asked, can you see images that have low annotation quality?
Yes.
Just sort by lowest annotation quality.
That's a great question, Joe. I can start talking a little bit about this. I think one of the issues here is that we're looking at the COCO dataset. This is a high quality label dataset, not the best one to show off. But when we select the annotation quality metric, which is based on the embedding spade and some clustering techniques that we apply, we can rank our images from the highest quality, so that's 1, as you see here in the image, to the lowest quality, which is 0. When something has a low annotation quality, that means that the embeddings from this specific object, so we actually see the horse here from before, the embeddings from this specific object is not similar to the embeddings from all of, the classes, not similar to all of the classes from the nearest neighbors in the embedding space. This works really well on specific use cases, but of course there's other use cases where we want to apply more advanced techniques. I hope that answers your question here, Joe. Any other questions, Stephen, before we dive into the actual Q&A?
Thanks, Nico. Absolutely. And in the same vein, can we also inspect the metrics on the, maybe we see a wrong annotation, for example? Can we look at the metrics tab, just see what's on there? I think that was one of the key things Joe wanted to see too.
Yes. So if we're on a wrong annotation here, let's take the elephant as a case. We can go to metrics where we highlight all of the quality metrics that we have in case. So in this case, it's going to be some really long numbers because these are just numeric values over your image and over your labels, but you can indeed go and inspect them. And then if you find an area that you think is interesting, let's say in this case, you are interested in finding sharpness between 0.0 and 0.03, we can then go back to our filters and apply that within our filters here. So we can go to our annotation and find sharpness, and then apply that specific threshold here. As such. So yes, you can indeed see all of the metrics.
Thanks, Nico. And can we also inspect the issues? When it says there are a total number of issues found, let's see what's in there.
Yes, so we can indeed. Let's go back here. So the issues that we highlight for labels are 4 here. We have the object aspect ratio. So these are the weird aspect ratios we saw before. Border closeness, so whether an annotation is right next to the border. The annotation quality, so this is based on a threshold on the annotation quality metric. And then the relative area of the object compared to the image. This is super interesting because we see that a lot of models are struggling with very, very small objects. And it's something that's very, very prevalent within the COCO dataset. So when I click one of these, you'll see that a filter is being applied in here, which gives you all of the results between 0 and 0.02 in your annotation quality metric. And you can then inspect them one by one.
Yeah, awesome. Thanks, Nico. I think we can go right into some of the questions that were pre-submitted and then head over back to the Q&A to answer the live questions.
Beautiful.
Perfect. All right. Yeah. Thanks again for sharing the demo. Just curious though, for the first question that was pre-submitted, how do you deal with data without labels? Do you have any advice? Because we've been talking with labeled data at this point with annotations, but when you have data with no annotation, how do you talk about this? How do you troubleshoot?
Good question. Good question. Thank you for asking that one, by the way. I would assume that in this case, you just started out creating a first data set and you're looking to figure out what to annotate next. So this is not a case where you're looking to do some kind of unsupervised learning without labels. So in this case, I would apply some of the techniques that we discussed today, of course, taking a bit more time to actually dive into my data set and use some of the embeddings-based and quality metrics-based approaches to data cleaning and curation, which does not require any model, given it sounds like you don't have a model. And you can also use the off-the-shelf metrics that are already within the Encord Active platform.
All right, perfect. And is it also available for image sequences?
Yes, the Encord Active platform. Yes, indeed. Currently, we support single images, image groups, sequences, and videos. And when you point this back to Annotate, they will remain in their respective format.
Perfect. Thanks. And the next question here is, how do I extract the hardest to classify or worst performing samples out of my data and cluster them to get an overview of the issues? I think that was one critical part of the demo you showed.
Good question. It's something we actually thought a lot about at Encord recently, and I'm looking to build out some functionality for this quarter. I can quickly show you some of our current pieces from the development process. So we're looking at clustering our data based on different low-performing subsets and highlight which image properties or metadata types are prevalent in those subsets. I think I brought one here. Yes. So this is an example from our beta, where you see to our right the different failure clusters that was found based on a machine learning model. And you can see specific clusters. For example, we can look at the cluster 1 here, where the position is 30% lower than benchmark at an area where the model confidence is low and the relative area of the annotations is low. So we're trying out different ways currently to figure out how to automatically cluster your data and your predictions to really help you find these problematic subsets easier.
Perfect. Next question is, what are the AI models used to build active learning approach? We get this a lot in the community, so.
Good question. So normally you'd use your own model, one of the off-the-shelf models as an input for the predictions you want to use in your active learning flow. And then I would recommend here to play around with some of the different acquisition functions that are out there to figure out what yields the best outcome for you specifically. In our internal test at Encord, the least confidence acquisition function seems to yield the best results across the board, I can also once again here quickly show a UI to see how this will look in Encord once we release the active learning smart sampling into Encord. So it's the one we see here in question, currently working with a title called Smart Collections, where you essentially select a sampling strategy. So this could be an acquisition function, a quality metric, diversity-based metric. Then you select your model predictions. So you can upload multiple sets of predictions. You select a sample size. Let's say you just want to sample 10% within your active learning workflow. And then you decide whether you want to balance across your different classes. You can also do some pre-filtering here on the right. And then we will create an async active learning job that will create this smart collection for you within a matter of minutes, instead of having to manually go and do all of your curation. I hope that answers the question here on active learning approaches.
Yeah, I think I should. And on the other side is talking about the best practices. And curious, this person is curious, what are your top 5 best practices for improving data quality, or just generally best data quality practices?
I think we covered most of these today already, but I'd always emphasize like the importance of good and thorough data cleaning and curation is just key wherever you go. So implementing some of the techniques we highlighted today is definitely going to get you really, really far. But also the fact that you're here in this webinar, the fact that you're already thinking about being data-centric in your approach, you're already a lot of steps in front of a lot of other people in this space. But if you want to talk more about data quality practices, just jump into our community afterwards and we can have a chat either there, we can jump on a quick call and discuss some of these things.
Perfect. What are the benefits of dataset reduction? Data quality?
I think here with dataset reduction, the person asking this question is probably referring to reducing the dataset during the cleaning and curation process. But of course, it depends here. With a dataset reduction, you'll definitely lower your annotation budget and your training costs. And if your baseline is already a very low quality dataset, you're also looking to gain some model performance gains here. Some of the users that we've seen do dataset reduction with Encord Active has achieved between 5 to 15% improvements on the MAP score across the board. So this is definitely something that is useful, and we've seen it work in practice. And if you want to read more about it, then you can take a look at some of the case studies on the Encord website afterwards.
Perfect. And is it possible to find label errors and mistakes made by annotators?
Yes, as alluded to earlier, it's a very important step in your data quality pipeline and should not be overlooked. You might have set up a very complicated process for your data labeling, within Encord, another data labeling tool, but it'll always be the needle in the haystack that makes a way through. And using a tool like Encord Active, you can find that needle in the haystack fairly easily. So by integrating a platform like Active and Annotate together, you can then also track whom on the team is performing worse, if this is of interest for you. As you saw before, Gorkim did a few poor annotations. So that might be something where you can find selective annotators and figure out who needs more training within a specific domain.
Perfect. Thanks for answering that. And is it possible to integrate my annotation platform with Encord Active?
Yes. We do help with custom integrations and imports from time to time, as data cleaning, curation, active learning is not really useful without an actual annotation tool. A lot of the end outcome of doing these actions is to annotate it and then afterwards train your models on it. And as presented earlier, my recommended approach here would be to find a platform that combines both of these things, because it will save you a lot of time on data migrations and converting your labels from one format to another when you go back and forth, and this DevOps part of it. So an added benefit here would definitely be the speed from creation to annotation and back. So these iterative cycles, these active learning cycles will be a lot faster if you use just one tool.
Awesome. Thanks for sharing that. I think I'm going to head over to the live questions. So the demo thanks for the demo. Do you use TSNE or any similar approach to obtain the embeddings for semantic segmentation? Obviously, the embedding side was one of the key things that we discussed. I'm just curious what your thoughts are there.
Yes, good question. In this case, we just use off-the-shelf clip embeddings. There's no specific approach to this one. But do get in touch with us afterwards if you want to discuss any potential use case for you, or you want to import your own custom embeddings.
Perfect. And I think that wraps up the live questions we had. It was quite intertwined with the demo, so it's all good.
Beautiful. Everyone, thank you very much for listening in today. It's been a joy. Just before we wrap off, I just want to give a quick shout out here to Stephen and the rest of the team. We have an Encord developers community on Slack where we help everyone with questions and answers on computer vision, training models, active learning, and where we all engage in different activities and topics. So please do either scan the QR code here or get in touch with us afterwards, and then we can stay in touch afterwards. And also, if you have any questions, we'll follow up afterwards with the slides on an email, and you can just ask directly to the sender of this email. Thank you much for this time, and see you all next time.
Yeah. Take care.